The next one, so we already did cotangent. How do I rewrite secant?
It's 1 over cosine.
Yes, and I forgot, you guys. Remember, this is the one where we have to let one side stay the same. So I'm going to let the right side stay the same. And then I can cancel out these cosines of theta, and that leaves us with 1 over the sine of theta, which is just equal to what? The cosecant of theta. And look, that's exactly what we wanted to get. Do you see that? Okay? You need to make sure in these problems that you are showing your work, okay? I am not assessing you on whether or not you know the answer. I know the answer. I gave you the answer, right? You have the answer right here. The answer to number 2 is the secant squared of theta. Your job and what you're graded on is showing the work of how you got there, okay? And without your work, I'm not going to be able to give you any credit at all. Is that clear? So look at example number 2. When you look at number 2, you see the cosecant squared of theta minus the cotangent squared of theta. What does that equal to? How do you know it's equal to 1? Right, because 1 plus the cotangent squared of theta is equal to the cosecant squared of theta. So if we were just to subtract cotangent squared of theta from both sides, we just get 1. So this numerator is equal to 1. And you can also see that by looking at your little green sheet at the Pythagorean identities, okay? This is one of those. Now in the denominator, is that another Pythagorean identity? Yes, what is it? Very good. So how do we get 1 minus the sine squared of theta? What's that equal to? Good. Very good. Did y'all hear Daniel? Patricia, what is this equal to, 1 minus the sine squared of theta? Use your little green sheet. Look at your 3 Pythagorean identities. Okay, there's only 3. Which one has sine in it? The first one. Good. So how can we rearrange it to get 1 minus the sine squared of theta? Or we could just, okay. All right, well, let's look at this. We have the sine squared of theta plus the cosine squared of theta is equal to 1, right? And we want 1 minus the sine squared of theta, correct? So all we have to do is subtract sine squared of theta from both sides. And that gives us cosine squared of theta is equal to 1 minus sine squared of theta. Do you see? So, what is 1? All right, do you see right here where it says 1 minus sine squared of theta is equal to? Very good, cosine squared of theta. So this is equal to cosine squared of theta. All right, so let's just rewrite this as 1 over the cosine squared of theta. And what is 1 over the cosine squared of theta equal to? Tiffany? Think about 1 over the... Perfect, right? Because 1 over cosine is equal to secant of theta. So this is secant squared. Oops, I just forgot that C. The secant squared of theta. All right, and guess what, guys? Guess what we left alone? Secant squared of theta. So they're equal. Do you see that?
Yeah.
We just verified that they were equal. Are there any questions? Yes. Okay, which problem? 3? Okay. You just want to do it? No. Well, yes and no. If you broke it up into secant over secant minus cosine over secant, then yes, but you can't just cancel them out and have negative cosine. That's not how it works. Excuse me, do you understand? Okay. That's not how I'm going to do it, just because I've kind of told you guys from the beginning that I really just want you to break up everything into sine and cosine and go from there. So I'm going to stick with just that one way. There are many different ways you can solve this, though, okay? Yes, ma'am. Would you say, Caroline? Yeah. Oh, yeah. Okay. So I'm going to X out of here. Anybody need this? Okay. So let's look at example number 3. All right. On example number 3, how can we rewrite the secant of theta, John Andrew? How can we rewrite the secant of theta? Good. So we have 1 over cosine of theta minus the cosine of theta divided by, as you said, 1 over cosine of theta, right? Now, we could try to combine like terms in the numerator, but we'd have to, get a common denominator. I'm not about that life. So what I'm thinking is I see lots of cosines. So I'm going to try to flip this, dividing by a fraction is the same as multiplying by the reciprocal. I'm going to flip this 1 over cosine and see if we can cancel some stuff out. So watch this, because this is important. 1 over cosine, we're dividing, so that's the same as multiplying by the cosine of theta over 1. And we're kind of distributing like backwards. Do you see this? So what is the cosine times 1 over the cosine? Theta. So that's just, well, that would be cosine of theta over cosine of theta minus cosine squared of theta. Do you see what I just did? Yes? Usually we would write this on the left, so it would look like this. Cosine of theta over 1, that's the denominator, times 1 over the cosine of theta minus cosine square, minus cosine of theta. This is just writing it a different way. And then we would distribute cosine of theta times 1 over cosine of theta is cosine of theta over cosine of theta. And cosine of theta times negative cosine of theta is negative cosine squared of theta. Do you all see that now? Now, what is cosine of theta divided by cosine of theta? So now we have 1 minus the cosine squared of theta. And what is 1 minus cosine squared of theta? When you see 1 minus cosine squared of theta, your brain needs to automatically say Pythagorean identity, right? Are you with me here? And honestly, once you see the 1 in the cosine squared of theta, you only have 2 options. It's either sine squared of theta or negative sine squared of theta. But we saw that this is what? What is 1 minus cosine squared of theta equal to? Sine squared of theta. And guess what we were trying to get it equal to? Oh, right here, look, sine squared of theta. Do y'all see that? Any questions here? You have a quiz tomorrow, so you need to ask me if you have questions.
All right, so we could do this in all different ways.
Yeah, all different ways. As long as you arrive at the same answer, I don't care how you do it. Okay?
Yeah.
But you need to show your work, okay?
Yeah.
All right, here we go. Let's go to the next one. So this one is, I don't like saying things are easy because I know that things that are easy for some people aren't for others. But of these problems, this one I would say is one of the least complicated, right? Because we're just going to leave sine of theta as sine of theta. And how do we rewrite the cosecant of theta? 1 over the sine of theta. I'm sorry, I forgot to identify. This is what we are keeping the same. Now, what happens when you divide by a fraction? So I'm taking this guy away, and I'm flipping him upside down. Instead of him being 1 over sine, he becomes the sine of theta over 1. Good. And what is the sine of theta times the sine of theta?
Sine squared of theta.
Which, guess what, is exactly what we're looking for. So do you see why I consider this one of the less challenging problems?
Yes.
Yeah? Okay, any questions here? Questions? All right, y'all ready to go to 5? I'm going to have to exit out of this just to give myself some more room. Now, what are we going to do on 5? We are going to distribute. We're distributing the love of trig. And some of you guys like to call this FOIL. I don't, but some of you do. So 1 times 1 is 1. Very good. And then what would I do next, Sierra? Good. So 1 times the sine of theta is perfect. And then what do I do next? Perfect. And that gives us negative sine of theta. And then over here, what does that give us? Negative sine squared of theta. And Sierra, I'm going to ask you one more question, then I'll move on. Can we simplify this? What happens? These cancel out, and we're left with 1 minus sine squared of theta. And guys, do we already know, have we already seen in a previous problem what 1 minus sine squared of theta is? Yeah. What is it? Cosine squared of theta. You guys were going to do these problems so much that, or you should have been doing them and continually doing them so much that this almost becomes like natural to you to just say, of course, it's just the sine squared of theta. Do you see? I'm sorry, to say that this is equal to cosine squared of theta. And guess what we wanted it equal to? Cosine squared of theta. We're done. Any questions? Are y'all with me?
Yeah.
All right. So let's continue. Let's go to the next one. All right, Hiram, help me out with this next one. So we want sine of theta to stay the same, right? We're going to have to get this one bigger. Hey, get your head up, please. Okay, could you? So we are on number 6. Okay, so this is just the sine of theta, and how can I rewrite the tangent of theta, Hiram? Perfect. Sine of theta over cosine of theta. And this is equal, or plus, my bad, plus the cosine of theta. And remember, this is what we're just going to keep the same. So then that gives us sine squared of theta divided by cosine of theta is, or plus cosine of theta. So let me ask you this question, Hiram. When you look at this problem, what are you thinking? Like, what are you thinking we could possibly do? Just guess. Guess something. Multiply, okay. Multiply by what? Well, we can't cross out the cosines, but you're right. Why would we want to multiply by cosine of theta? Because it's a fraction, right? And we would multiply the one on the right because we want to get a common denominator, right? So you kind of just have to look at this and say, what can I do with this? And what you can do is get a common denominator and combine your terms. So let's get a common denominator. That means we need to multiply cosine of theta by cosine of theta over cosine of theta. Okay, and this ends up giving us the left side. This doesn't change. This is still sine squared of theta divided by cosine of theta. And over here we have cosine squared. It's a plus sign. Over here we have cosine squared of theta over cosine of theta. And guys, remember with fractions, when we add them, we combine the numerators and the denominators stay the same. So when I combine the numerator, this becomes sine squared of theta plus cosine squared of theta over cosine of theta. But Hiram, what is the sine squared of theta plus the cosine squared of theta? 1, right? Have we almost memorized that? We've done that so many times. Okay, so this ends up giving us 1 over the cosine of theta. And what is 1 over the cosine of theta equal to, Hiram? Secant of theta. Very good. And guess what we were trying to find, Hiram? Secant. All right. Are there any questions here? And yes, the front and back of this is your homework, guys. So the rest of this is your homework. All right, let's go on to number 7. All right, on number 7, we want to keep this right side the same. And how could we rewrite the secant of theta, Kevion? Very good, 1 over the cosine of theta. And how can we rewrite the cosecant of theta? Kevion? Very good. When we divide by a fraction, Kevion, it's the same as multiplying by the reciprocal. Very good. So that means we're going to take this 1 over sine of theta, and we're going to flip it upside down and make it the sine of theta over 1. Now when we multiply across, 1 times sine of theta is sine of theta, and 1 times cosine of theta is cosine of theta. And Kevion, what is sine of theta divided by cosine of theta? And Kevion, what did we want to find this equal to? Tangent of theta. See how nice things work out? Okay, now the next section, which would be numbers 8 through 18, it is my bad on not putting directions on there. I apologize. It should say for you to just simplify, okay? Which means just get it as simple as you can. It's pretty much the same exact thing we've been doing. We're just not told what it's supposed to be equal to. Is that clear?
Yeah.
Okay, so let's go ahead and look at number 8. All right, on number 8, what is the cosecant squared of theta minus the cotangent squared of theta, Alyssa? Number 8. Okay, well, we know the trig identity that represents this, right? What's that trig identity? I'm sorry, the Pythagorean identity. Yes, ma'am. Is equal to cosecant squared of theta, right? So we just need to manipulate this equation so it looks like this on one side. How can we do that? Okay, we could add cotangent to both sides, okay? Or so, you mean subtract cotangent? You mean subtract cotangent? Because look, the cotangent's negative here. So that gives us 1 is equal to the cosecant squared of theta minus the cotangent squared of theta. Right, Alyssa? So do we know what this is equal to? Just 1, perfect. Okay, now Alyssa, stay with me. While you're on this problem with me, let's look at number 9. Because number 9's like the same thing, it's just a little different. What we did on number 9 is we had this same equation, which is 1 plus the cotangent squared of theta equals the cosecant squared of theta, right? Except for in this problem, we need the cosecant to be negative, right? Okay, and we could do that by moving it over, correct? So let's go ahead and subtract the cosecant squared of theta from both sides. And that ends up giving us 1 plus the cotangent squared of theta minus the cosecant squared of theta is equal to 0. Well, we don't want that 1, do we? How do we get rid of it?
Subtract.
Very good. We subtract it from both sides. And that ends up giving us the cotangent squared of theta minus the cosecant squared of theta is equal to -1. So in number 9, our answer is -1. That's a lot of work. You don't have to really do all that work, okay? What you can say, you either know it's 1 or -1. And if you can't easily just subtract one of these guys to get it, then it's going to be -1. Do you see what I'm saying? Yes?
I think what I should do after doing the study guide is study this green sheet. And
Yeah.
um,
Good. That's an excellent idea. Okay, let's continue. On number 10, what's the answer to number 10? Do we have to do something similar for number 10?
sort of similar.
Sam, what is the trig identity that is, what is the Pythagorean identity that's associated with number 10?
Tan squared circle thing
Tan squared of theta,
plus 1 equals
secant squared of theta? Okay, so what do I need to do here to get it this way?
subtract secant
Okay.
square theta. And subtract the 1.
Okay, do we want to subtract the 1?
Maybe.
What do we want to get by itself?
So
We're actually going to subtract the
the
tangent squared of theta. Do y'all see why I would want to subtract tangent squared of theta here? Because it leaves us with exactly what we want, which is 1 minus the secant squared of theta is equal to negative tan squared of theta. So what's our answer, guys?
negative 10.
It's negative tan squared of theta.
Yeah.
Any questions? You really have a 50-50 chance on this problem, and that's because you can look at it and say, I've got a 1 and I've got a secant. I'm only missing the tan squared, right? So it's either positive tangent squared or negative tangent squared. Okay? On number 9, 50-50 chance. You see the cotangent squared and the cosecant squared, which means you're missing 1. So it's either 1 or a negative 1. If we're really not feeling like doing all this work. I mean, that's pretty good odds, right? No, I'm showing you how to do it, and if you're refusing to listen and refusing to study, I am giving you at least some hope. Are there any questions? Okay, let's look. Number 11, what does that equal to? Let me draw a card. Alexia. Number 11, 1 minus the sine squared of theta. Okay, but so what is 1 minus the sine squared of theta? What would that be equal to? Very good. Cosine squared of theta. Are we feeling good about this? We know that one, don't we? Yeah. All right, good. So let's continue. Yes, ma'am. Go ahead. All of them? No, I mean, you could have solved 8, 9, 10, 11 like that. That's how we solved them, is using the trig, the Pythagorean identities. Yeah, that's how we solved all of those, by using. You need to show some type of work on when you're verifying, right? But since I'm not giving you the answer here, you don't have to show your work. Does that make sense? I would recommend showing your work because sometimes you'll get confused whether it's positive 1 or negative 1, or positive tan squared of theta or negative tan squared of theta. Do you understand? Yeah. Okay, well, let me finish. Alexia, did I answer your question? Do you have another question? Yes, Daniel. Can you give me a second to go over this and then we'll get to the back? I know we're running out of time, but yeah. Oh, yeah. You're solving. I'm sorry, I also didn't put directions on the back. You're just solving. For theta is between 0 and 360. Greater than or equal to 0 and less than or equal to 360. All right. Let's look on here. So what about any of these problems you want to see worked out? What about 18? What is 1 plus, yes? 14, okay. All right, 14. What is secant of theta equal to? 1 over the cosine of theta. So then we have 1 over the cosine of theta times the cosine squared of theta, right? So if we multiply across, that just gives us the cosine squared of theta divided by the cosine of theta. Think of it, we have 2 cosines in the top and 1 in the bottom. So then we cancel 1 out, and that just gives us the cosine of theta. And that's your answer for number 14. Do you see? Other questions? Can we do 18 real quick? Oh, yeah. Samantha, what is 1 plus the cotangent squared of theta? Okay, do you guys see how she saw that? She saw the 1, she saw the cotangent squared. She immediately went to her Pythagorean identities and saw that this is just the secant. So we already have sine of theta, and we're multiplying that times the secant squared of theta. And this is going to be very similar to 14, or kind of similar to 14. So what is the secant squared of theta, guys? Actually, let me ask someone. Jada, what is the secant squared of theta equal to? 18. Oh, no, you're absolutely right. This is a cosecant, sorry. Cosecant squared. Do you see that? Yes? Okay. Whose turn was it? Jada. On number 18, Jada, what is the cosecant squared of theta equal to? Very good. 1 over sine squared. So we have the sine of theta times 1 over the sine squared of theta. And that's going to equal the sine of theta over the sine squared of theta. And what do we do now? This we cancel, and we get 1 over the sine of theta. But what is 1 over the sine of theta equal to? Cosecant of theta. That would be your answer. Are there any questions? Do you have a question? T? Yeah. Yeah, I think so. All right, any questions here? Okay, let's continue. Are there any other questions on this front page? Okay, questions on the back page? Yes, ma'am. 29? All right, on 29, we would subtract 2, divide by 2, and we'd get the cotangent of theta is equal to -1. Did you get that far? Now, cotangent is just the reciprocal of what? And tangent is the reciprocal of the cotangent. So we know we have a tangent button on our calculator, so the tan inverse of -1 is equal to what? It's equal to 1 over the cotangent, which is not going to change much because it's -1. Let me show you over here on number 30. You know you'd still need to find the angle in all this. Okay. So we're not done with 29 for those of you watching this video. You still need to find the two, you need to find out when theta is, what the value of theta is for the tangent of -1. So over here on secant, we want to add 2, and we get the secant of theta is equal to 2, but we don't have a secant button on our calculator, do we? What we do have is we have a cosine button, and remember that the cosine of theta is equal to 1 over the secant of theta. So cosine of theta is equal to 1 over 2. So then we would put in our calculator to find theta, the cosine inverse of 1/2. Does that make sense? Right, the reason it's weird on 29 is because it doesn't, since it's 1, it doesn't really change. You're going to get the same no matter what. Okay? But if you look at 28, let me look at that real fast. On 28, oh, there's not one like 28. I guess those are the only two. Yeah. Not like a lot, but that was like one of the last things we did, and I felt like it was kind of easy, so I didn't put a lot of those problems on the study guide. Okay? Does that make sense? All right, are there any questions? But yes, for the cosecant, guys, for the cosecant, for the secant, and for the cotangent, when we're solving, you do need to rewrite that in terms of sine, cosine, and tangent, and they're gonna have to flip to the reciprocal, okay? Are there any questions here? Your homework is the front and back of this, and the key will be on Schoology. Please remember that I have tutors